Access control lists, ACLs, are an essential part of a well-designed and maintained network. They provide an essential piece of the puzzle to control traffic and protect data. ACLs provide packet filtering and can be implemented on routers, multi-layer switches, and firewalls. ACLs are used to define interesting traffic and can be used for a variety of purposes including security, traffic direction, and QoS. ACLs can be used as a part of the mechanism to permit, deny, classify, and mark traffic to secure, optimize, and protect the network. QoS can be implemented by using Cisco's Modular QoS Configuration, MQC, which includes class maps to define the traffic, policy maps to apply the rules, and service policies to activate them on an interface. ACLs serve as packet filters and can be implemented at various points in the network. On perimeter routers, it's common to implement an ACL that filters out known problem traffic, such as traffic sourced from a private address space that doesn't belong on the internet. On interior routers or layer 3 switches, ACLs can be implemented for security and QoS purposes. They can permit or deny traffic going through the device to and from certain destinations and applications. The ACLs can be implemented as standard ACLs, which only filter on source address, whereas extended ACLs can filter on source and destination address, as well as source and destination application and protocols. Named ACLs make use of a descriptive name such as block HTTP, which makes it easier to remember the purpose of the filter. It's important to remember that ACLs are only one aspect of security and that they're only part of the overall solution and architecture of the network. An example of how ACLs can be implemented is to think about a connection between a web server and a database server. The web server might reside on a demilitarized zone, or a DMZ, which is an area that has a lesser security level than an internal network. The database server would reside on the internal network and therefore have a higher security level. ACLs could be implemented to only allow access from certain web servers and specific applications on the database server to decrease the vulnerability footprint. Another example of ACLs could be implemented for QoS purposes when dealing with latency-sensitive traffic such as voice and video. In the case of voice traffic, we would mark it at the edge of the network and then match it with an ACL and place it into a priority queue. The voice traffic in the priority queue would be serviced before any other traffic, and only when the priority queue was empty would traffic in the other queues be serviced. Through this mechanism, we ensured that the voice traffic gets the highest priority and service available on the network. Special care should be taken when creating and implementing ACLs because they can sometimes have unintended consequences if not implemented correctly and tested thoroughly. ACLs test traffic in a top-down manner in which the order of the rules in the ACL become very important. When an ACL is implemented, the traffic will be tested against each statement in order until a match is made to either permit or deny. If no matching entry is found in the ACL, then there's an implicit deny any, which is invisible but at the end of each and every access list. Testing of ACL should be done in a lab environment if possible. Then the ACLs should be moved to the production during off hours or during a change management window. Finally, a comprehensive checklist of before and after the ACL implementation should be completed along with a contingency plan for backout or reversal if things don't go as expected.